Okay, with this video, the main thing I want to point out with you is this little trick about dividing by z before you start. So for example, and let me grab a pen here. So suppose I want to find the inverse z transform of u of z. Now you might be tempted to say, okay, well the order of the numerator is the same as the order of the denominator, so let's first divide out the 1 here then to get a proper fraction, so that we can separate our factors this way, where we get 1 plus a over z minus 1 plus b over z minus 0.5. Now the problem with that is that when you look this up in the table of z transforms, you're not going to find it. Rather, you'll find a z over z minus 1. So in order to work with this, then you've got to somehow get the z in here and then put it out here, which then is a delayed version of the step plus the delta function. So it ends up being rather unwieldy. However, if we were to do this problem again and instead of doing it the way we did before, we first divided by z. So we take out one of those z's. So we end up with this expression. And we separate this out and find the a and the b using regular partial fraction expansion methods. We'll end up with, now we'll put see here's the a equals 2 and the b equals -1. But we've taken the z and put it back in. So now we have the z's, and now these are direct table lookups from the textbook. Okay? And then this other one, this next one shows another trick. I'm looking for the inverse z transform of f of z. So what I'm looking for here I have a quadratic. Now you could try to factor this, but if you try to factor it, you're going to find that it's got complex poles. So what you're going to want to do is decide, well, is this a pure sinusoid or a damped sinusoid? Well, if it's a pure sinusoid, this would be 1. So that's not the case. So we're looking at two tables. We don't know whether it's a cosine or a sine or a combination. So we look at rows 20 and 21 in the table that give this, where we're going to let this be equal to 0.5 and see then what form we have here. Now it's pretty clear that we do not have a factor of z minus something in the numerator, so that it is really just row 21 we want to look at. So what we need to do then is determine what these quantities are so that we can compute this and this. Okay, so let's look. So we've set this equal to the 0.5, and we can find e to the minus at, which is what we're going to need in the numerator here. We also know that this middle coefficient has to be equal to 1.2. So that allows us to find the cosine of bt. And once we have the cosine of bt, we can find the angle or any of the trig functions that are associated with that. So now we take this row in the table, and what we had was 2z over this, and in order to put this, to make it look like the table without changing it, we also have to divide by this. So this part here converts to this part, and then here's 2 divided by what we had to divide by in order to get the table entry. And so this is our inverse z transform. Okay, that's the end of this video. That should give you a pretty good start on some examples for the z transform.